Hello viewers, in today's class we are going to discuss one more important limit involving greatest integer function, right? So here we have to evaluate this limit at the point x is equal to 2, right? So when x approaches towards 2, we have to find the limit of sine greatest integer of x plus 2 divided by greatest integer of x plus 2, right? So let us see whether the limit of this function when x approaches towards 2 exists or not. Now from the concepts of limits, we know that the limit of a function exists at a point or at a given point if the right hand limit exists and finite, and the left hand limit also exists and finite, and moreover both these limits should be equal, right? Then we say that the limit of a function exists. So now here we'll first evaluate the right hand limit and then the left hand limit, right? And then we'll see whether both the limits exist or not, or if exist whether they are equal or not, right? So let us start, and let us first take the right hand limit. Now the right hand limit of this function when x approaches towards 2, that is from the right of x is equal to 2, is written as RHL, and we can write limit x tends to 2 plus, and we have sine of greatest integer of x plus 2 divided by greatest integer of x plus 2, right? And here the positive sign shows that we are calculating the right hand limit. Now let us put x is equal to 2 plus h, right? Because we are calculating the right hand limit, so we have to take x is equal to 2 plus h, where h is a very small quantity but it is greater than 0. It implies that h should be positive, right? So now when x tends to 2, obviously h tends to 0, right? So now this right hand limit, it can be written as limit h tends to 0, and for x we can replace x by 2 plus h. So we have sine of greatest integer of 2 plus h plus 2 divided by greatest integer of 2 plus h plus 2, right? So we can simplify it. Limit h tends to 0, we have sine of 4 plus h, greatest integer of 4 plus h, and here also we have 4 plus h, right? Okay, now we have to assign a value to this expression, that is greatest integer of 4 plus h, and when h tends to 0, right? Okay, now as we have just said that h is greater than 0 and h is a very small quantity, right? So h when added to 4, it means 4 plus h is slightly greater than 4 but it is less than 5, right? Why? Because h is greater than 0 and h is very small, and when we add h to 4, this quantity 4 plus h is slightly greater than 4 but it is less than 5. So by definition of greatest integer function, the value of greatest integer of 4 plus h is equal to 4, right? So now this expression can be rewritten as limit h tends to 0, and we have sine of greatest integer of 4 plus h, and the value of greatest integer of 4 plus h is 4, and here also we have 4, right? So now here we do not have any term containing h, so this limit is obviously equal to sine 4 over 4, right? So the right hand limit of this function when x approaches to 2 is equal to sine 4 over 4, right? So now viewers, let us find out the left hand limit. So the left hand limit is given by limit x tends to 2 minus, and we have sine of greatest integer of x plus 2 divided by greatest integer of x plus 2. So now here, in order to evaluate the left hand limit, what we will do, we'll take x is equal to 2 minus h, right? Because in this case, the value of x approaches to 2 from the left of x is equal to 2, right? So we'll take x is equal to 2 minus h, and again h is a positive quantity and it is a very small quantity, and when x tends to 2, h tends to 0, right? So now this limit in terms of h will take the form limit h tends to 0, we have sine greatest integer of x plus 2. So for x we have 2 minus h, and here we have plus 2, and for this greatest integer of x plus 2 we have 2 minus h plus 2, right? So now this is the limit h tends to 0, we have sine greatest integer of 4 minus h, and here also we have 4 minus h, right? Okay, now we can explain the value of greatest integer of 4 minus h on this similar lines. So see, h is a positive quantity, right, and it is a very small quantity, and when h is subtracted from 4, right, so when h is subtracted from 4, then 4 minus h is obviously greater than 3, but it is slightly less than 4, right? And by the definition of greatest integer function, the value of greatest integer of 4 minus h, when 4 minus h lies between 3 and 4, is equal to 3, right? So now this limit can be written as limit h tends to 0, we have sine of 3, right? For greatest integer of 4 minus h we have 3, so we have sine 3 over 3. Here also we have greatest integer of 4 minus h, and this is also 3, and again here we do not have any term containing h, so the limit is equal to sine 3 over 3, right? So viewers, here we can clearly see that the right hand limit is not equal to the left hand limit, right? So the right hand limit is not equal to the left hand limit. Therefore we can conclude that the limit of this function when x approaches to 2 does not exist, right? Because sine of 4 over 4 is not equal to sine of 3 over 3, right? So the limit of this function when x approaches to 2 does not exist, because the right hand limit is not equal to the left hand limit. So this is how we solve this problem based on limits.